Okay, calculus is concerned with how a change in one quantity, whoops. Is concerned with how a change in one quantity is related to a change in another. And that's why we talk about slope so much, right? How a very small change in x will affect y. Okay. So what happens when a function approaches a value this is called a limit. Okay? So when do you use limits? You use limits for things you can't actually calculate. You use limits around asymptotes. Okay, because if you think of an asymptote, they will not actually have a value on the limit, but you can see it's going to be, if you think of the graph of 1 over x, right? This is the perfect one for limits, okay, because you can't actually get to 0. If you could, you'd have a value of infinity, though. The same thing over here, going this way, you can't actually get to 0, but you have negative infinity. So that the limit of this would be infinity, you can't actually get there. And well, it deals with the questions we just dealt with, okay? Because remember how I said we sort of cheated and divided by 0, okay? When we get those A and H questions, you're not really allowed to divide by 0. But using limits, you can, because you're not actually getting to 0, you're getting 2.00000000000000001 or whatever. Similarly, you can also do a limiting to check what the value is going to be when something gets to infinity, right? You can't actually get a value of infinity, but as you move over this way, you can actually figure out what it's getting close to. Yes?
So is a limit just like a statement that you put before, or?
Sort of. I'll go through it a little bit here. It's basically what a limit is. It's basically what we've just done. Like the basic limit is sort of what I'm leading you into here, except we'll get to things that are more complicated.
But is it going to be an algebraic?
Oh, it's a total algebraic, yes. Okay. I'm going to say limits only exist if the left side and the right side are equal. For example, back to the graph of 1 over x, the limit doesn't exist at x equals 0 because it's not tending towards the same value. Right? On the one side, it's going to be infinity. On the other side, it's going to be negative infinity. So it doesn't actually exist. We'll talk more about that on Friday. We're going to say many limits can be evaluated by inspection. This is boring. What did Mr. Lacey call it? Not boring. What does Mr. Lacey say? Do you guys remember, Dakota? It wasn't boring. It was, no, it was like tedious but monotonous. No, what was it? I can't really say. Nick, do you guys remember what he said on the board here? It was something like that.
I remember when he did it, I just don't remember.
It wasn't, I liked it. It was like, it wasn't boring. It was, I can't remember what he said anyway. Many limits can be evaluated by inspection. If anyone thinks so, please let me know.
Was it just simple but elegant?
Simple but elegant, that's it. Simple but elegant. Inspection, that's direct substitution. These are boring. Most that we will see in this course will be exciting.
What makes them boring?
Because they're simple?
An exciting limit is something that's 0 over 0 or infinity over infinity, right? Or something that as soon as you sub in directly, doesn't work. So like when you were saying, Reed, you just asked me before, you said, why can't I just sub A and H in originally instead of having to do all that algebra? So the question we just did in the board is an exciting limit. Because if you just sub in the value that up to 0 divided by 0.
Our real question, is
Yes.
exciting limit the correct term for that? Like what?
I don't know if there's it's every one you will see in calculus from here until you stop taking calculus. Okay, so I don't want to call it a boring. I'll show you an example. Here's example 1 is a boring limit. Okay.
Boring is a very...
Okay, boring. What are boring ones? It says that direct substitution will work.
Yeah.
Example 1 is boring. Okay.
One over X.
Okay. Example 1 says the limit as x approaches 2 of 3x squared minus x minus 4. Okay. What that little limit sign is, it's like f of 2. That's basically what you're saying. Okay, the limit of x approaches 2 basically means f of 2. So the first thing we do is substitute it in, see if it'll work. Okay, so we're going to sub in x equals 2. This is a boring limit because what happens when I sub in x equals 2? Who are we up to, by the way? Spider-Man. Shannon, can you sub in 2 for x? Tell me what we get.
So it would be 3 times 2 squared.
Yeah.
Subtract 2.
Yeah.
Subtract 4.
Yeah.
Which would be 12.
Yeah.
Subtract 2.
Yeah.
Subtract 4, which would be equal to 6.
Good. So that is a boring limit. Okay, but what they're saying is basically there's a point on the graph. 3 and 6 is a point on the graph is basically what they're saying. Now when x equals 3, y equals, or the equation equals 6.
So if we limit infinity, do we sub in infinity?
Yes, you would. We'll do that today too.
0.36
The internet will ignore my mistakes. I'm too excited here, okay? That wasn't boring, okay.
Yeah,
You know it's a boring limit, I'm so excited about it, okay? Because example 2 is where the thrill is coming. We're going to say here, I'm going to finish my notes and we're going to stop. I'm going to say if direct substitution ends with a 0 over 0 or infinity over infinity. This is called an indeterminate limit. Okay. That's the exciting limit, is the indeterminate limit. We have the options too. And I'm going to change this a little bit from the way Mr. Lacey said. Because wasn't one of his options use magic? I think that was one of his options for evaluating. Intuition is limits, is that I don't like magic in math. Okay, so I'm going to tell you the 4 steps to use. Number 1 is to factor and simplify. Anytime you can factor in life, please do so. Number 2 is rationalizing the numerator or denominator. I'll give you an example of all of these. One-sided limits. Four is divide by x. And 5 is change of variable. That's it for the note. The rest of the 3 is examples. Okay. Remember what you're trying to cancel out. Okay. There will always be one thing that's causing you a problem. If you think of today's examples today, when you're divided by h, you're trying to remove the h. Okay. In every single type of question, there'll be one thing that's causing a 0 or an infinity. Think of what it is and get rid of it. Okay. That's the issue then. So coming back now. And you guys will get tortured with this for your first weekend university calculus. I hope that most will be taking this in university. I'm going to hit pause on my video, and then we're going to start doing examples the rest of today's class.